Hey guys, here's a quick video in case you're having trouble with the polyatomic ions. Polyatomic ions do the exact same thing as regular ions. They just look different. This right here, HCO3-, his name is bicarbonate, but it's going to act exactly the same as your elements did, like Cl- when we did chlorine, because it was Cl-. This does exactly the same thing. It's just bigger. Let's look at the example and work through this example together. I've written a little bit more here so that we can see a little bit more information. Our example was NaHCO3. This is two ions. Na, sodium, we know him. He's off the periodic table, easy. He's Na+. I know what HCO3 is because I have this table. You are not inventing polyatomic ions. You're not trying to figure them out. Just use this table. It's all you need. I know it's HCO3- because I went back and checked the table. When I put them together, I follow my rules. Do my charges even out? A +1, a -1. Yes, they evened out. So I can just put them together as NaHCO3. I name them based on the rules. Rule 1 from way back here was start with the name of the metal, the positive ion. So I started with the name, sodium. I used bicarbonate because that is that ion's name. I come over here, it told me. HCO3-, his name is bicarbonate. So I named it sodium bicarbonate. Let's look at your assignment today. Sorry, I'm going to touch everything before I find the proper page. Found it. Front page, you should know how to do it. Front page is simple, same ions. The back page is where it's polyatomic. With a polyatomic ion, I just check their charges, put them together. So for this first one, I have NH4, which if we go back, that was ammonium. That was a +1 charge. Chlorine is a 1- charge. Those even out. So I can write them as NH4, and I have to reach up here to make it a subscript, because that's what ammonium is, and then Cl. I can make that a regular size. It's a little bit harder on the computer. You might want to write these and just take a picture. That's what its formula would be, because NH4+ and Cl- are a 1-to-1 connection. NH4 is a whole object. He comes together. Cl is a whole object. They come together. To name it, I look back at my chart. I look at that and I say, oh, that is ammonium. And then the Cl, that's chloride. So NH4Cl is ammonium chloride. I can do the same thing with this second one and break it apart. HCO3, that was on my polyatomic ion list. That was bicarbonate. Li, that's just a normal element. That's lithium. So I know here, first off for naming, I've got lithium and I have bicarbonate. That's his name. To separate them, I look over here and I remember lithium on our periodic table, he was a +1 charge. Again, if I spend the time, I can make these subscripts and superscripts. Then I come over here and I have HCO3 and he was a -. Hold on, again, superscripts and subscripts, hard on the computer. But I can do this and I know that it's HCO3-, not because I'm amazing. I read the chart we made. That chart tells me that answer. So now on here you've got 2 examples completed. I hope this helps make a little more sense.